In this video, we're going to look at the definition of independence for two events, and then we're going to look at two examples and determining from those two examples whether those events are independent or not by using the definition. In one case, we're going to use a Venn diagram and identify whether it's independent, event A and B, and then from the other example will be of a chart. We'll have some chart data and we'll determine whether the events A and B are independent. Let's talk about independent events. So there's a simple test to decide if two events are independent. And that is the test that you see here. That is, if two events are independent, then the probability of one happening times the probability of the second one happening equals the probability of them both happening. Okay? So all we have to do is we need to find the probability that A happens, the probability that B happens, multiply them together, and if that is the same as the probability of the intersection, which is the same thing as the chance of both of them happening together, then we know they are independent. So let's do two examples. Let's look at a Venn diagram, and then we will look at a chart, because charts and Venn diagrams basically can show the same information. So let's talk about this example on the left. We're going to look at this example here on the left and decide whether these are independent events. And we're going to use our definition of independence to make that determination. So what can we know? I want you to stop and figure out what is the probability of A, the probability of B, and the probability of A intersect B, and then decide if they're independent events. So pause the video and make that determination. Okay, I assume you've now made the determination. So what is the probability of A? Now the probability of A is the probability that anything inside here is happening, right? So that would include the 0.3 and the 0.1. So this is the chance that A is happening. So that's 0.4, 0.3 plus 0.1. That's the 0.3 plus 0.1. What is the probability of B? Similarly, the probability of B happening is the chance that they both happen plus the chance that just B happens. And so that's going to be 0.3. Now, what is the probability of A intersect B? Well, the probability of A intersect B is everything in here, right? It's everything that, it's where does A and B both happen together. And so that's equal to 0.1. That number is given to you. It's given to you right here. Okay, so now we have to simply make the determination. Are these independent? And we can just apply our formula. So now the question is the probability of A times the probability of B, does that equal the probability of A intersect B? Question mark. Well, just 0.4 times 0.3, well, we know that equals, if we pull out our calculator, that's 0.12. Does that equal 0.1? And the answer is no. No. So these are not independent events. Okay, so let's move along, and we're going to let's do the same problem, but now we're going to do it using a chart. So we have this chart where A can happen or B can happen. And so they both happen 10% of the time. Neither one of them happens 45% of the time, right? And this is the chance that A happens. And this is the chance that B happens. In fact, we could draw this like a Venn diagram, and let's just do that for fun. So the chance that, A happens and B happens would be 10%. The chance that A happens and B does not happen is 30%. The chance that B happens and A does not happen is 0.15%, leaving 0.45%. That's like our W, So this is what the Venn diagram looks like. But we don't need to draw the Venn diagram to solve this problem. Don't need it at all. So what is the probability of A? Well, the probability of A, again, is everything is the probability of A, regardless of B. So that's 0.4. The probability of B is this, so that's 0.25. The probability of A intersect B is where they're both true, and that's 0.1. So now the question is, are they independent events? Let's run our test. Right? Does the probability of A times the probability of B equal the probability of A intersect B? Well, we just put our numbers in. 0.4 times 0.25. Dyslexic Dad, dyslexic Dave, equals 0.10. Because if you type into your calculator 0.14 times 0.25, it equals 0.1. So yes, these are independent because the probability of A times the probability of B equals the probability of A intersect B. And we'll end this video here, and then we're going to move on next to do some other truths of probability.